Today is lesson 4.5, ASA and AAS. ASA stands for angle, side, angle, and AAS stands for angle, angle, side. So the first thing we're going to talk about is the ASA congruence postulate. This says if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So what we mean by this is if we look at our picture, we notice that angle A has been marked congruent with angle D. And we also notice that angle C has been marked congruent with angle F. And then we see that side AC has been marked congruent to side DF. And so the reason that this is angle, side, angle is that we have two angles and the side that is in between them. So remember in our last video, we talked about how we always start with an unmarked side. So if I start with AB, because AB is an unmarked side, and I choose to go around clockwise or counterclockwise, what do I get to first? Well, I see an angle that's been marked congruent, a side, and then an angle. So notice the side has to be in between the two angles for these to be congruent by angle, side, angle. So that's what we're looking for, a side being included in between two angles. And if that's true, then we can write the congruent statement, and remember the order of those letters does matter. So notice that angle A, when we say triangle ABC, A was listed first, and then D was listed first because angle A and angle D are congruent. And likewise, we have angle C. We know angle C and F are congruent to each other. So C and F are in the same position. And then, of course, obviously the unmarked angles, angle B and angle E, are in the same position. So the order of those letters does matter when we write that congruent statement. So just be careful as you write that. And then we also have the angle, angle, side congruence postulate. This says if two angles and the non-included side, so this one is the two angles and a side that is not in between them, if they are congruent in one triangle to a second triangle, then those two triangles are congruent. So here we have angle, again, angle A is still congruent to angle D. And then we still have angle C, and it's still congruent to angle F. And then this time we change the side, and the side is side BC is congruent to EF. And so if I start with one of those non-marked sides and I go clockwise or counterclockwise, either way, I hit an angle first, then I hit another angle, and then I hit a side. So this would be angle, angle, side. So that side is not in between the two angles. It is not included in between them. So if this is true, angle, angle, side, then those triangles are congruent. And again, we need to watch the congruent statement and how we write that. So we now have 4 ways to prove triangles congruent. Instead of proving all 3 sets of sides and all 3 sets of angles are congruent, we now can shorten that and prove that only 3 pairs of specific things are congruent. So the first one we talked about was side, side, side. So if we're going to use side, 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 that means all 3 pairs of the corresponding sides are congruent to each other. That way, if we know all 3 sides are congruent in one triangle to another, that means that those triangles are congruent, which means all 3 pairs of angles and all 3 sets of sides are congruent. And then we had side, angle, side, which said 2 pairs of corresponding sides, and it's important that we say the included angles are congruent. So if we can prove that 2 sides and the angle in between those 2 sides are congruent in both triangles, then those triangles are congruent. And then today we just talked about angle, side, angle. which says if we have two pairs of corresponding angles and the side that is included in between those two angles, then the triangles are congruent. And then last but not least, we also now have angle, angle, side. So two pairs of corresponding angles and either of the non-included sides would have to be congruent, and we could say those triangles are congruent. So we're cutting our work in half. So instead of proving 6 pieces are congruent, we now only have to prove 3. So we're going to look at some examples. Does the diagram give enough information to prove the triangle is congruent? If so, write the congruent statement. So as we're looking at our picture, remember we talked about how we always need to mark anything that has not been marked in my picture already that we would know. So we do know right now that side KJ has been marked congruent to MN. And we also see that angle K has been marked congruent to M. But we also know from chapter 1 that vertical angles are congruent. So in this picture, angle KLJ is congruent to angle MLN because they are vertical angles. So since those are vertical angles, we can mark those congruent. And so now what I'm going to do is I'm going to choose an unmarked side, and I'm going to go clockwise or counterclockwise to determine whether I can use this triangle or not. So I'm going to start at JL, that's my unmarked side, and I'm going to go counterclockwise this direction. And you'll notice I hit an angle first, then another angle, and then a side. So this would be angle, angle, side. So I do have enough information to prove that this triangle is congruent. I can prove this triangle congruent by angle, angle, side, and then I do have to write that triangle congruent statement. So I'm going to take my first triangle and I'm going to put the letters, I always like to do it in alphabetical order just because it's easier for me. So if I look at this first triangle, and that's the first triangle I'm going to name, I'm going to color it in blue so you know which one I'm talking about. We're going to call that JKL. So triangle JKL is congruent to, and then you have to look, angle J is an unmarked angle, so the unmarked angle in the other triangle will be angle N, so those are corresponding angles. And then angle K has been marked with a yellow arc mark, and so has M, so K and M match up. And then angle L obviously will match up with angle L. If we look at B, we see angle B has been marked congruent to angle E. And we also see that side AB has been marked congruent to side DE. But I do not know any other postulate or theorem that would tell me that anything else is congruent to each other, whether it's sides or angles. So since I only have 2 pieces of information here, this is not enough information. I need to know that 3 sets of corresponding sides or angles are congruent, and they also have to be in a specific order. So that one is not enough information. Example C, again, we're going to look to see if I can mark anything else. Right now, I do know that angle E is congruent to angle J. And I also see that side EF has been marked congruent to side JH. And then I know from Unit 1 that angle EGF is congruent to angle JGH because those are vertical angles. So now I do have 3 pieces of information. I just have to see, is it in the correct order for me to use this? And so what I'm going to do is pick that unmarked side again. I'm going to either go clockwise or counterclockwise. I'm going to go counterclockwise. I guess that would be clockwise, I'm sorry. And I come to a side first, then an angle, and then an angle. So while I went around that way, side angle, angle isn't one we know, but if I were to switch it around and go this way, that is angle, angle, side, which we can use. And so there is enough information. We're going to say that these 2 triangles are congruent by angle, angle, side. side. And again, I'm going to go in alphabetical order. So I'm going to start with the triangle that is on the left. So I'll color that one in red so you know which one I'm talking about. So that we're going to call it triangle EFG. Triangle EFG is congruent to triangle, and you'll notice that E has been marked with the green arc mark, and so has J, so J has to come first. F is the unmarked angle, and so is H, so H would be in the middle, and then obviously G would be the last one that I would have to put in there. Example D, all we have so far is that side NQ has been marked congruent to side MP. But I do know we talked about that any shared side we can always say is congruent to itself. Just like you look at yourself in the mirror, you are the same shape and the same size. So NP, I can say NP, side NP is congruent to itself since it's in both triangles. However, those are only two pieces of information and I need at least three. And so I know nothing else about this figure because I didn't tell you that any of those lines were parallel. I didn't tell you that any angles were cut exactly in half. And so I can't just make up that information. So for this one, there would be not enough information for us to draw a conclusion. Not enough info. Then we have letter E. Letter E, we see that we have two right angles. And if we have two right angles, that means both of those are 90 degrees. And I know that two 90-degree angles, if they measure the same, they are congruent. So I can mark those angles congruent. Also, I see that they share side EG. So I can mark EG congruent to itself. But if I'm looking at that triangle, I don't know anything else about that triangle. And so unfortunately, I only have two pieces of information, and so there is not enough info to prove that these triangles are congruent. For letter F, we do see that angle PRQ has been marked congruent to SQR. And we also notice that angle QRS has been marked congruent to angle PQR. So I have two sets of angles that have been marked congruent to each other. And then I also see that they share side QR. And so I'm going to mark QR congruent to itself. Now, I do have three pieces, so I just need to ask myself, is this a valid method for me to use? So I'm going to choose an unmarked side. So I'm going to choose QS, and I'm going to go clockwise here. So if I go clockwise, I come to this orange angle first, the green side, and then the yellow angle. And so that is angle side angle. Angle side angle is a valid way to prove a triangle congruent. So we are going to say yes, there is enough information. This will be angle side angle. And so we have triangle, and I'm going to name this guy on the top first. So I'm going to color him in, and we're going to go with PQR. So we're in alphabetical order. Notice the P is the unmarked angle, and so is S. So S would have to come first. Q has been marked with two yellow arc marks, and so has R in the other triangle. So R would come next. And then R in that shaded blue triangle has been marked with one orange arc mark, and so has the Q in the unshaded triangle. And so our triangle congruent statement would be triangle PQR is congruent to triangle SRQ. Okay, on the last ones, you just have to state whether there's enough information and which postulate you would use, because we can't write the congruent statement because there aren't letters to do so. So in letter G, we see that we do have two sets of angles already marked congruent. So now what we're going to do is we're going to look at, is there anything else I can mark? And there is. I can mark the shared side congruent. So if you notice, if I go from an unmarked side and I go around either way, it doesn't matter, I come to an angle and then a side and then an angle. So that is a valid way to prove triangles congruent. So we can say that yes, these are congruent by angle, side, angle. And in letter H, right now, I have two sets of sides that have been marked congruent, but I do know that the shared side can also be marked congruent to itself. And so that one's fairly easy because we see all three sides that have been marked. So this one is congruent by side, side, side. All three sides in one triangle are congruent to all three sides in another triangle. Letter I do have two pieces of information right now. I see a set of angles that have been marked congruent. I see a set of sides that have been marked congruent. And then I know that vertical angles are congruent, so I now can mark a third set of corresponding pieces congruent to each other. So I'm going to start at an unmarked side, and I'm going to go clockwise or counterclockwise, and I'm going to see if the order will work. So I come to an angle first, then a side, and then an angle. Angle, side, angle is a valid way to prove triangles congruent. So yes, there's enough information. We are using angle, side, angle. And then this is a very similar picture because really the only thing we've changed is that instead of marking these congruent, they were marked with right angles, and we know that right angles are congruent. So we have a set of angles that are congruent. We have a set of sides that are congruent. And then obviously our vertical angles are congruent as well. And so again, this is almost the same exact picture. We are just going in a vertical method, then horizontal. So I come to an angle first, then a side, and then an angle. So again, angle, side, angle is a valid method. So these two triangles are congruent by angle, side, angle. And last but not least, angle K. Angle K, if we look at angle K, we already have two sets of sides that have been marked congruent. We have the set that has two tick marks. We have the sides that have 3 tick marks. And then I know from Unit 1 that vertical angles are congruent, and so I can mark my vertical angles congruent. And then I'm going to start at an unmarked side, go clockwise or counterclockwise, either way. I come to a side, an angle, and then a side. So side, angle, side is a valid method as well to prove triangles congruent. So there is enough information. We're going to do side, angle, side. So we have 4 unique ways to determine whether two triangles are congruent: side, 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 angle, side, angle, side, angle, and angle, angle, side.